Now that we've explored how AI can power various use cases within our Explore California case study, it's time to dig deeper into the tools and standards that will help us build these AI systems efficiently and responsibly. Scikit-learn is a core Python library for building and evaluating ML models. It provides a simple interface to powerful tools for data pre-processing and model training, all tightly integrated with the broader Python data ecosystem, which consists of libraries such as NumPy, Pandas, and Matplotlib, amongst many others. We'll start by using some pre-built NLP methods available in Scikit-learn, like TF-IDF vectorization and stop-word removal, to kick off our text analysis. These are simple but powerful ways to get value out of raw text without needing an LLM. In our recommendations initiative for our Explore California case study, we'll be using traditional ML techniques to predict which product best matches our user preferences. We'll also explore more advanced models like LightGBM, a high-performance gradient boosting library which is commonly used in tabular machine learning tasks. We can integrate LightGBM models seamlessly with the Scikit-learn API. This means we can plug into the same workflows for cross-validation, pipelines, and hyperparameter tuning, whilst gaining improvements in both speed and predictive performance. We can also use Scikit-learn with popular deep learning frameworks such as Keras and PyTorch to build even more complex models. If you're working with structured or lightly processed data, Scikit-learn should be a default part of your toolkit, giving you both speed and control as you experiment and iterate with machine learning solutions. Next up, Hugging Face Transformers is one of the most popular libraries for accessing state-of-the-art language models and embeddings in Python. When we want our AI systems to understand language beyond simple keywords, we need models that capture semantic meaning, the actual intent and context behind a sentence. This is a perfect use case for our sentence transformer embeddings. These models, including BERT-based variants, convert entire sentences into dense vectors, allowing us to compare text inputs based on meaning rather than just exact word matches. We'll use the Hugging Face Transformers ecosystem to access and apply these models to generate embeddings to power our semantic search explorations with our Explore California data. We'll also explore how to run local language models directly in our Google Colab environment. This workflow gives you full control over your data, improves latency, and removes dependency on external APIs, which is ideal for privacy-sensitive or offline applications. These tools are perfect for AI systems without always needing a cloud connection. And thanks to the Hugging Face Hub, trying out the latest models is incredibly easy, often requiring just a few lines of Python to get started. However, let's talk trade-offs between local and cloud LLMs. When deciding between running a local model, like a Tiny Llama or Mistral, on your own machine using Hugging Face Transformers versus using a cloud API like OpenAI's GPT-4 or Anthropic's Claude, there are a few considerations. Privacy. Local models keep your data fully offline. This is ideal for sensitive use cases. Speed. Local models avoid network latency, but often require decent hardware, especially for larger models. Scalability. Cloud APIs are easier to scale and maintain, especially for production use or high traffic. Cost. Local is free once it's set up, whilst cloud usage is often metered, priced by the number of tokens which are used. Model size. Local models are typically smaller, around 1 billion to 7 billion parameters. This might limit complexity, but allows for faster inference. Token limits. Cloud models tend to support much longer context, up to 128,000 tokens, while local models usually tap out at 4,000 to 8,000 tokens. In our projects together, we'll experiment with both approaches so you can see when a small, fast local model is good enough and when it's worth reaching for a more capable cloud-based LLM. Remember our smart AI travel assistant agent that can answer questions and call dedicated AI tools? You could write all of that from scratch in pure Python, or we could use a framework like LangChain. LangChain abstracts away some of the plumbing, letting you define agents and tools more easily, chain together prompts and actions, and also integrate with vector databases, APIs, and LLMs quickly using modular code components. But it's not a magic solution for all AI problems. We'll learn both the raw Python and LangChain approaches so you can understand what's happening under the hood and develop a deeper connection to all the various AI components we'll cover. As AI systems become more capable, two emerging standards are helping define how agents interact with tools and services: the OpenAI protocol and the Model Context Protocol, also known as the MCP. The OpenAI protocol establishes a consistent format for interactions between users, assistants, and systems, along with structured tool calls. It allows LLMs to perform tasks such as searching the web, executing code, or querying databases using well-defined functions. The Model Context Protocol, MCP, developed by Anthropic, builds on this by enabling tools to describe themselves dynamically to the model. This gives LLMs the flexibility to decide which tools to use based on the task and available context. This is an essential step towards more autonomous and context-aware agents. Together, these standards make it easier to build composable, interoperable agents, whether you're using LangChain, Hugging Face transformers, or any other AI frameworks to build your AI systems. Just as REST standardized how web APIs communicate, these AI protocols are laying the foundation for the next generation of intelligent agents. So far, we've explored the key tools, models, and trade-offs that form the foundation of modern AI systems, from traditional machine learning with Scikit-learn to powerful language models using Hugging Face transformers to real-world architecture choices like local versus cloud-based LLMs. We've also touched on important frameworks like LangChain and the emerging standards that are shaping the future of agent-based AI. But this is just the start. We'll learn how to apply these tools and frameworks to solve real problems and create our own intelligent systems from the ground up.